So our last unit was about quadratics, and now we're moving into polynomials. So these units are actually very closely related. So what we learned about quadratics is it always has a certain form of equation, whereas you have y equals ax squared plus bx plus c, and it always made a parabola. So it always made this U shape, either going up or this U shape going down. So you'll notice the equation, in order to be a quadratic or a parabola, you always had to have x to the squared, and that to be the highest degree. If it was x to the third, it wouldn't work. And what we learned about quadratics is if I have my x and y axes here, one of the big things we did was use the quadratic formula to find where it crosses x, here and here. And remember, we get two solutions, and sometimes we would get one solution if, let's say, this was my x and y. And so if your vertex of the parabola was on x, then you only got one solution. For here, you would get two solutions when you use the quadratic formula. And sometimes you get zero solutions. For example, if my parabola was like this, where that vertex was above or below, and it never crossed the x-axis, we get zero solutions. So that quadratic formula, the negative b plus or minus, and you have the square root and all of that over 2a. So that was one way to find where it crosses. And that was a pretty complicated way, and it took a lot of work. So this next section on polynomials, we're going to get into a new way on how we can find these zeros. And it's called factoring. So what we're going to learn all leads up to factoring. We want to know how to factor because that will give us these solutions, which is actually a much easier method than the quadratic formula. The thing about factoring, though, is there's some things we need to know first about how polynomials work. So thinking about this term polynomials, the prefix poly, do you know that that means many? So that just means there's more than one term. So for example, we could have a polynomial like 2x plus 4. That has two terms, so it's a polynomial. If I have like 3x squared minus 2x plus 4, that would have three terms, here, here, and here. We could have lots of terms. I could have 4x to the 5th minus 3x to the 4th, and I could keep going. Notice that we usually put these in order. Now these are called degrees. This exponent here, this has a degree of 5 because that's what the highest exponent is. And we usually organize them from the highest degree to the lowest degree. Now, I don't have an x here. There would be like, let's say minus an x here and then plus 5. And then it has all of them. But they don't have to. You can have a polynomial that's 3x to the 4th minus 1. It doesn't have to have every degree in between. But these are all different kinds of polynomials. And when we get to factoring, we're going to be multiplying and adding. And so we used our exponent rules. We know how to multiply using our exponent rules. But adding is the next thing, is we're going to be talking about adding polynomials, subtracting polynomials, adding like terms. And this is where none of these are going to be like terms. Like terms mean they have to have the same exponent. So that's what we're going to get into next, is how to add like terms, and then multiplying, finding the greatest common factor, and all of those things are needed for us to get to how to factor. So that's kind of your introduction on what we're looking at next.